Okay, we're going to go ahead and go over chapter one. By now, you should have read the chapter. You also should have read what was on Angel about chapter one. Chapter one is going over the basics of computing. So it's talking about hardware and software, what they are, how they interact with each other. Then it goes on to talk to you about programming languages, what's a CPU. This is all important because you have to know the basics to really understand the beginning of any programming language because it all derives from that. The different types of programming languages. Remember, I told you to download Visual Studio Express Edition, and that's the IDE, which is a integrated development environment, and it's also in a compiler. So that's nice because you can take that programming language that you write in there and it can turn it into something tangible. You see in here that it talks about syntax, what that is. It's talking about binary languages, which is how computers talk through the use of zeros and ones. It talks to you about source code. I really hope that you're reading through this because it's important that you understand these concepts because you're going to see them later on in pretty much all the chapters. You know, there's going to be some consistency about the terminology. So it's important that when you read this, you're actually understanding what you're reading. If you really don't, Google the word, look it up on Wikipedia, see some references, some examples, and it'll help you to remember it better. Okay, if we move on through the chapter, it's talking to you about pseudocode, and it's also talking to you about understanding the program development lifecycle. And if you look on page 8 of your book, it has there for you a diagram. You also will see that diagram in the PowerPoint. If you went through the PowerPoint, all the diagrams in the book are in the PowerPoint. So when you look through that, you should be thinking about what is the program development cycle? You know, like why should I know that? What is the programmer trying to do? What is the problem they're trying to solve? So that's basically number one, right? You have to understand what the problem is. You have to plan the logic behind the problem, like how are you going to attack that problem? What are you going to do to solve that problem to make it easier? The third thing you need to do is code the program. Next is use software compiler or interpreter to translate it into programming language or machine language, excuse me. And that compiler that we're going to use in this class would be Visual Studio, because we're going to go ahead and start just doing some really basic stuff on Visual Studio, just so you can get a feel to see what it's like, what it does, and you know, if you decide to take a more advanced programming class, at least you'll be familiar with how it works. The fifth thing on the development cycle is you have to test the program to see if it does work. If it doesn't work, you have to go back and get the bugs out. The bugs would be like any problems that are in there, any warnings. You have to go back and fix it, and make sure that you put your that you're using the right programming terms, that you're not missing any of the characters that are needed. So that's important. The sixth part of this development cycle, we put the program into production. So that means to go ahead and have a test environment for it, have someone, like if you were creating a game, have someone play the game, someone figure out if the game works, if it's fun, you know, that kind of thing. You know, like what needs, is it too slow, is it too fast, is it crashing? Those are the type of things that you would think about when you're putting the program into production. And then the last thing is to maintain the program. You have to be sure that whatever program you write, someone else can come behind you and fix something if it went wrong. And also, like if you write a program now, a basic program like how to wash the dishes. I go to the kitchen, I put the stopper in the sink, I turn the sink on, I put the dishwashing liquid in there, and the water runs, right? That's not the whole process of how you wash the dishes. You might do the first part of your code, but someone might have to come behind you to do the second part of the code to complete the act of washing dishes. So that's going to be like maintaining the code and adding to the code. So that's the last part of the development cycle. So you need to understand these type of things because they kind of go full circle and you have to understand why. So I hope that you're reading through this, trying to get a feel for it. Definitely Google. Google is your friend because there's so much information on Google and there's examples, there's more detailed documentation, there's just all kind of things that can break it down even in easier format for you if it's kind of confusing now. But as you start learning different things and hearing different vocabulary words and concepts, the more you hear it, the more you see it, the more you'll understand it. So this is just, our first week, first chapter. So just give it some time and you'll be good at it. So let's go on, keep going through the chapter. The next important thing I wanted to point out in the chapter was on page 18, where it has the comparison of a flowchart and a pseudocode. And as you can see, the pseudocode is kind of like real world English that for a programmer, basically. It's real world English for a programmer, so that you can like write out what you want to do before you actually put it in a true programming language. So the pseudocode here is like inputting a number to get an answer. You have to do start, then input the number, then set the number, then get an output, then stop, right? So it's showing you how do you write that in pseudocode and how do you write that in a flowchart format. And this is important for you to kind of look at and get familiar, like what's the difference between a flowchart and what's the difference between a pseudocode and how are they similar? Because in this class we're going to be using both flowcharting and pseudocode. And we're going to work with the compiler to put our programs into a compiler to get it to do something. So that'll be fun. Touch on is on page 24, where it just shows you kind of like examples of the Microsoft Visual Studio. Now this is an older version, but it still looks similar to the one that they're showing you, the screenshot they're showing you in the book. Remember, we're going to be using the Express 2010 edition. Make sure that you download that and that you just open it up, read the documentation I put with that, and just so you can play around with it. And then I'm going to give you more detailed documentation later in chapter 2 so that you can start or practice your own code, do your own code. It'll be fun. So coding is great. It's fun. It's exciting, especially when you get your output. It's really cool. So I'm excited about it. I hope you guys are getting excited about it. And I will be back with chapter 2. Please read the chapter, watch the videos, do the assignment, and do your quiz. Don't get behind, guys. It's the first week. We're going to get this spring semester started real good. We're going to get it going and going and going and going so that we can get a good grade. Yay! And be done with class. Okay, bye.